Okay, so with this PV equals nRT equation that we're talking about on page 9 of your packet, this is our third and final gas law that we have an equation for to plug into. And as you might notice about this gas law as opposed to our combined gas law that I've just written over here, notice how we have the same P's, V's, N's, and T's in this ideal gas law, but there's only one of each. There's not this one side and the two side. So this combined gas law is for when something changes about our gas and we're trying to predict or figure out what everything else is going to do when that pressure, volume, or temperature is changing. Our ideal gas law does not deal with changes. We just have one pressure, one volume, one moles, one temperature getting plugged in. This is used to solve kind of mysteries, to figure out the missing values from our gases. So if I knew my volume, my moles, and my temperature, as well as this R that we're going to talk about, I could use those to solve for my pressure if I didn't know the pressure or I couldn't measure that pressure. So that's how we know when to use this equation. And as I pointed out, really the only thing special or new about this equation, other than the fact that it's simpler, smaller, with only one of each variable, is the R. And as you see right underneath that equation, R is what we call the ideal gas constant. And there's actually 3 different values for this ideal gas constant that we have to choose from. And that's really the big deal with this equation, is how do we choose it? And as that next bullet point tells us, we're going to use the pressure unit provided in the problem in order to decide which R value we're going to use. And down here we have a nice simple table. If you see any ATMs in your problem, this is the R value you're going to use. KPA, use that 8.31 number. MMHG, 62.4. But you don't actually have this nice straightforward table on your equation sheet. What you will have on your equation sheet are these 3 values written out just kind of in a line with the units that go along with them. And those units are really how we can tell what pressure unit we should be looking for. Notice how most of these units are exactly the same. They all have liters, moles, and Kelvin there. But the one part that's different is that pressure unit that you see down here in the table. So if you have ATM in your problem, go find ATM in these units, and that's going to tell you and point you towards which R value to use in your problem. KPA, still 8.31, MMHG, 62.4. So it's a little bit less obvious when you have these big crazy units off to the side there that you have to use than compared with this table. The table definitely does help, and you can use that while you're working here in your packet, but you will not have that table on tests and quizzes. You will only have these values written out with their units like this. So you've got to get comfortable using those units to find which R value you need to plug in. Other than that, it's mostly just going to be plugging things in, but just like we have to be very careful and specific about the units in our pressure and making sure it matches our R, we also, as always, have to make sure that our temperature is in Kelvin, and we have to make sure our volume is in liters. So in our combined gas law, we didn't care whether it's milliliters or liters, but this has to be liters from this equation. So I've reminded you here that 1 liter is equal to 1,000 milliliters, but when it comes down to it, if you have a number like 650 milliliters, I wouldn't start trying to do dimensional analysis or math in my calculator. All we've got to do to turn milliliters into liters is move the decimal left 3 times. Essentially, we're dividing by that 1,000 to turn those milliliters into liters. So that would be 0.650 liters. So just make sure. I don't think there's any problems in our notes that actually have milliliters in them, so it's mostly those practice problems on page 10 that go along with these notes. You're going to have to be careful of that, and I will remind you of that at the end of this page. So let's go ahead and look at that first problem. Actually, before we get there, this is really the key to working out these problems, I think, without making mistakes, because you can just plug in all the numbers and do algebra with all of the numbers you know in order to find the number that you don't know. But when it comes down to it, I see a lot of people make algebra mistakes if we're trying to solve things like this, which is still perfectly fine. Just plug in all the numbers you know and then try and do what you need to do to solve for n. It still works just fine, but I see people make mistakes when they're trying to do all of this math, dividing by the wrong thing. So I think one of the things that makes this equation way easier is that we can rearrange it ahead of time in order to solve for whatever we're looking for using a very simple trick. Unknown, whatever we're looking for, is equal to the opposite side of the equation over our neighbors. So I'm setting up the 4 equations that we might want to use to solve the problems down below. P, V, N, and T. We're never going to solve for R. R is a constant. It's one of those 3 values. We're never going to be asked to solve for it. So here, if I was solving for P, the opposite side of the equal sign is nRT. So I'd be putting that on top. And then P's neighbor is V. So if I multiply N times R times T, divide by V, that'll get me my pressure. And then it's a very similar equation for V, because the opposite side of that equation is still nRT. We're just going to be dividing by P instead. Now when we come over to find N's equation, the opposite side of the equation from N is PV, and it has 2 neighbors, R and T. So PV over RT, and then our temperature is going to be PV over NR. And we do have to be careful about how we plug in these numbers in the equation. When we have more than one number on the bottom, you're probably going to have to use parentheses to make sure that you multiply them together, but we're dividing by the whole quantity. But we'll talk about that when we get to one of these example problems. But these are fairly simple problems. Find the numbers, plug them in, choose the right R, but then the calculator process of how we plug it into the calculator is really going to be what gets us and is extra important here. So let's look at our first problem now. This one is asking us what volume, so V is what we're looking for, would be occupied by 0.625 moles. Moles is always N. At 4 atm, that's our pressure, and 37 degrees Celsius. That's our temperature, but I'm going to go ahead and turn that into Kelvin, of course. So at this point, if we know we're solving for volume, you might start by writing out your volume equation just to get things set up and ready. And if you start plugging your numbers into that equation, bringing down our N, you're going to pretty quickly realize, oh, I need an R value. Let's go look at our R values and figure out which one we need to use here. And because we have ATM as our pressure, then I need to use the one that has ATM in its units. So our R value here is going to be 0.0821, and then times 310 and divided by 4. So at this point, we need to multiply across the top, divide by 4, and you can plug that all into your calculator all at once if you'd like. And the unrounded answer that we end up getting here is 3.9767118. That's definitely way more numbers than we need. And just like our combined gas law, where we round this answer is going to depend on all of the values that we got from our problem. The only number that doesn't count towards our sig figs in our rounding is that R value. So if we look at this, we had 4 sig figs, 3 sig figs, and 3 sig figs. So we keep the least number of sig figs in our answer, which means we want to keep 3. So we want to keep the 3.97, but then that 6 is going to round our 7 up. So 3.98 is our final number answer. And because this was a volume, just like we have to put liters in for our volume, then every time we get an answer out for our volume with this equation at least, it's going to be liters. Hopefully that wasn't too bad. Let's try another one together, because that third one I'm going to ask you to do just like I asked everyone in class to do that one on their own. So here we're trying to find our moles of gas. So N is what we're going to be looking for. We have a volume of 2.2 with a pressure of 1.2 and a temperature of 298 Kelvin. So our N equation here is PV over RT. And as we start plugging in numbers, P times V over R, which R do we need to use? Pressure is in ATM again, so it's going to be that same 0.0821. Make that look more like an 8. There we go. And our T. Now, I need you to take a moment and plug this into your calculator. I know your calculator might not be the exact same type as what we have at school, but I know everyone can kind of do algebra slightly differently, and you might use your calculator slightly different. Just push slightly different numbers. What I need you to make sure is that you're still getting this 0.1079 answer out. If you're getting something like 3,000 or 5,000 or even like 0.0001, very small answer, then you're plugging this into the calculator wrong. And so I want to help you with how we can put that into the calculator. I'll have to help you once you get to school and can ask me questions. But if that's showing as an issue, make a note to come check in with me. Try it again maybe when you're in class with my calculators. But then I can help you with how you're plugging it in to make sure that it's going to get this kind of answer. So please try that out. And this final answer, because we are going to need to round this down to 2 sig figs because we have these 2 sig fig numbers here, we're going to get 0.11, and then of course N is moles. So next problem is up to you. You do this one. If you're doing it correctly, your answer should end up between 10 and 15. And this is going to be another 2 sig fig answer, so try your best to round this to 2 sig figs. So coming back to problem 4, it honestly isn't that big of a twist, but there is a little something special that is happening here in number 4. And maybe you tried out number 4 after number 3. And if you did, hopefully you're getting 16 liters as our final answer, which I will join you in getting in just a moment. But if you start looking at this, this seems originally like it's just like our first problem. We're looking for volume, and so we need our volume equation, nRT over P. And we've got our pressure here. Our temperature is 310. But the one thing we do not have here is moles. No moles at all. So how can I solve this problem if I don't have moles? You might have realized there's another number over here we haven't used yet that's in grams. We can't plug grams in for moles. Those are not the same. It has to be moles for N. But we can use a little bit of our dimensional analysis stoichiometry skills in order to turn these grams into moles, just with the help of the periodic table. So if I look at, because we've got grams on top, I want to cancel that out. So I'm going to go and look at the mass of hydrogen on the periodic table and make sure to multiply it by 2. So that's what this number is, grams on bottom, to cancel out with the grams we have here. Then the opposite side of our grams is 1 mole of that same substance. Now, the substance doesn't really matter here because this whole problem is all about hydrogen. But later on this unit, we are going to do something a lot like this with our gases, and we are going to be changing substances. So it might be a good idea to keep track of those substances as well. Now, my unrounded answer was 2.48, but I would need to round that to 2.5 moles because we did have a 2 sig fig number giving us those moles. So this is the number we're going to use as our N. And at this point, as long as I choose an R value correctly, then I should be able to just plug it in and solve. If you weren't getting the right answer on that last problem, one of the things you might not have done is choose the correct R value. So here, because we have KPA, I'm going to have to be using 8.31. If you weren't getting an answer between 10 and 15 for that previous problem, then you might go back and check what units you have and see if you use the right R value, because it might not be the same one that we used for all of these other problems. So that is all set up, and if we multiply and divide, then this does end up being 15.7, but then we round it up to 2 sig figs, because yet again, just one 2 sig fig number means we have to round our final answer down to match those 2 sig figs. So that's our notes. Grams are really where things can get a little bit tricky, so look out for grams. Grams, whether they're given to you or asked for, means you're going to have to do some dimensional analysis. And like I said, that first question on page 10 is where you're going to start seeing some milliliters stuck in here. So remember, we have to change milliliters to liters. So move that decimal 3 times to make those liters. Anytime you see it anywhere on this page, every time we use this equation, we got to have liters. And then question 7 is definitely a bit weird, and I've made some notes here about how it's collected over water, so we need to do some subtracting of water pressure before we actually calculate the moles. And that's one of the problems that asks for mass. Well, we can't solve for mass on its own, so we're going to have to solve for moles first, and then we're going to do some dimensional analysis to turn those moles into grams. But with all the craziness that's going on in 7, most classes asked me to help them out with that problem. It's not the kind of thing that I'm going to put on your test where I combine all that craziness into one problem. So if you're struggling with some of those little bits and pieces of it, don't worry, I won't ever throw that much at you at once. But keep in mind, all the answers for all of the odds I've assigned you on page 10 are on Canvas, so even if you missed these notes, you can go on Canvas and check your work and try and catch up on your own. Let me know if I can help.